Problem number 3 reads, a skier starts from rest down a 30-degree slope. The coefficient of kinetic friction between the snow and skis, mu sub k, is 0.1. What is the acceleration of the skier down the slope? Let's take a look at the skier. The 30 degrees referred to in the problem is the angle between the slope and the horizontal. The coefficient of kinetic friction is given as 0.1. The skier slides down the slope, accelerates down the slope. Our problem is to determine what that acceleration is down the slope. Let's label it A. And before you try to work this problem, I want to put down a few forces acting on this skier. There is, of course, the weight of the skier acting straight downwards, mg, where m is the mass of the skier. In this problem, we also have a frictional force which acts opposite to the direction of motion. Let's label that small f. And we also have the force of the slope on the skier, the normal force, which is perpendicular to the slope. There is a relationship between two of these forces. The frictional force is equal to the coefficient here of kinetic friction multiplied by the normal force. All right. With that information in mind, then, try to solve that problem for the acceleration down the slope. I have added to our free body diagram an x and y coordinate system with the skier at the origin. The x-axis is parallel to the slope. The y-axis is perpendicular to the slope. Newton's second law can be written that the sum of the forces acting upon a mass is equal to the mass times the acceleration. That can be written in terms of the components of those forces, that the sum of the forces in the x direction is the mass times the acceleration in the x direction, and the sum of the forces in the y direction is equal to the mass times the acceleration in the y direction. If we examine our forces, we would find that the normal force lies along the positive y axis. The frictional force F lies along the negative x-axis. The acceleration that we're looking for is along the positive x-axis. The weight mg lies neither along the y-axis nor the x-axis, but we can break it down into components along the x and y-axis. An x component along our x-axis looking something like that, a y component like that. The x component we can displace and also right there, and then evaluate these components. We have a little triangle here with a right triangle with included angle 30 degrees, the same as the angle made by the slope. A side mg. The y component then would be mg times the cosine of 30 degrees. So that's our y component. The x component we can write as mg sine 30 degrees. Then if we use Newton's second law, writing it first in the x direction, we could write in the positive x direction we have downwards mg sine 30 degrees. In the negative x direction we have our frictional force F, little f. This is equal to the mass times the acceleration in the x direction, which is just the acceleration a that we're looking for. If we write in the y direction, we have, in the positive direction, we have our normal force n. In the negative direction, we have mg cosine 30 degrees. This is equal to the mass times the acceleration in the y direction, which happens to be 0. There is no acceleration in the y direction, so all that is equal to 0. I can rewrite then that n is equal to mg times the cosine of 30 degrees. We also have a relationship between F and N. The frictional force is the coefficient mu times the normal force. That coefficient was 0.1, so I can write that the frictional force is 0.1 mg cosine of 30 degrees. We want to take this frictional force, this expression for the frictional force, and substitute it into this equation. Rewriting that equation, I have mg sine of 30 degrees minus the frictional force, which now can be written 0.1 mg cosine 30 degrees is equal to ma. We notice that in this equation the mass m appears in each of the terms and therefore can be canceled out, and we are left with that a is equal to g sine 30 degrees. That's 9.8 meters per second times the sine of 30 degrees, which is 0.5, minus 0.1 times g, 9.8 meters per second, times the cosine of 30 degrees, which is 0.866. This gives you 4.9 meters per second minus 0.849, if you round to 3 significant figures, meters per second, that gives us an acceleration of 4.05 meters per second when we make that subtraction. So that is the acceleration of the skier down the plane, 4.05 meters per second, and that is the solution to our problem. Let us move on then to our next problem.